Hello everyone, welcome to the continuation of our series on systems of equations in application. In this lesson, we are going to talk about one of the most classic system of equation problems, and it's one of those problems that we often hear. It's almost made to be this scary thing about trains are traveling at this speed, heading on this track in opposite directions. When will they crash? So we're going to demystify that problem and make it seem a lot simpler. There's actually three ways we're going to look at these kind of distance, rate, and time problems. The first one will be objects traveling at each other. Then we're going to be looking at when they travel in opposite directions. And finally, when one is catching up to the other. Okay, so let's take them piece at a time. The first example, we're traveling at each other. It says two joggers start from opposite ends of an 8-mile course running towards each other. One jogger, Franz, is running at a rate of 4 miles per hour, and the other, Hans, is running at a rate of 6 miles per hour. After how long will the joggers meet? How far did Franz run before he met Hans? So, setting up a table like this with distance, rate, and time will help to solve this system of equation, because we actually are going to employ a trick where we might not even see a real system develop, even though we are still solving this basically with a system of equations. So let's plug in all the information that we know about this problem. So we know that the time it takes for, we know the rate that it takes for that Franz is traveling in as 4 miles per hour, but Hans is going faster. He is going at 6 miles per hour. Now, how long will it take for the joggers to meet? That's one of our questions. So we do not know how long it will take. Now, the distance that Franz and Hans travel, we don't know those either. Those are another piece of the pie that we don't know, but we know that Franz's rate times his time will be 4x. So that is the distance he's going to go. And Hans will be 6x. So he will travel 6x, Franz will travel 4x by using the fact that we know that rate times time equals distance. We know that their times are going to be the same because they're basically, it's going to be the time until they meet. So that's the same amount for both of them. So we also know that Franz's distance plus Hans's distance must be the total distance. So Franz's 4x and Hans's 6x is equal to a total of 8. So this basically is already to the point where we basically substituted in. We've basically skipped over the part where we had two individual equations, and we've jumped right to the system where we've made kind of a substitution in here, where we've got both of their distances together must be the total distance that they've traveled. So we're really home free here because we can solve this equation quite quickly. So 10x equals 8. So we divide by 10. And then we get that x is equal to 4/5. What does that mean? Since we are talking about miles per hour, this is the time. We said x is time in hours, so 4/5 hours. So that's how long it took the joggers to meet. So how far did Franz run before he met Hans? Well, we know that Franz's distance is 4x. So Franz is 4 times that 4/5. Which would equal 16/5. If we want to make that into a decimal, that's 3.2. So let's kind of sum this up and answer the question fully. Franz ran 3.2 miles before meeting Hans after 4/5 hours, and if you don't like 4/5 hours, 4/5 hours would be 48 minutes. Great. So that's when two objects are traveling at each other and we don't know the time that they're traveling for. So we can put x for our time. Okay, what about if they're traveling in opposite directions? So Bob and Fred start from the same point and they walk in opposite directions. Bob walks 2 miles per hour faster than Fred. After 3 hours, they are 30 miles apart. Okay, so how fast did each of them walk? So the fact that we don't know their speed tells us that we're going to have variables in our rate. Now it says Bob walked 2 miles per hour faster than Fred. So I'm going to let x be Fred, and Bob then must be 2 more than that. Well, we know that they both walked for 3 hours, so that's our time. So what would our distance be? Well, rate times time is distance. So here, 3 times x plus 2, and here, 3x. So those are the distances that Bob and Fred both traveled. Well, we know that those distances that they each walked will lead to them being 30 miles apart. So 3 times x plus 2, Bob's distance, plus 3 times x, Fred's distance, must now be a total of 30 miles apart. So we can solve this. We can distribute 3x plus 6 plus 3x equals 30. So 6x plus 6 equals 30. We'll subtract 6. We'll get 6x equals 24 and divide by 6 to get that x is equal to 4, meaning that Fred traveled at a rate of 4 miles per hour, and Bob, then too faster, traveled at a rate of 6 miles per hour. So let's put that into a nice answer to our question. Fred walked at 4 miles per hour, 4 miles per hour, and Bob at 6 miles per hour. Wonderful. They didn't ask for how far each of them walked. We could have found that if we wanted to. We could take their speeds, put it in there. So if Bob is traveling 6 miles per hour times 3, he traveled 18 of the miles, and Bob traveled 12 of the miles. Fred traveled 12 of the miles. Okay, now what happens if one person is trying to catch up to the other person? So here we have Daryl leaves his house traveling 2 miles per hour. Daryl's brother Daryl leaves 6 hours later to catch up with him, traveling 8 miles per hour. It's an inside joke. If you get it, good for you. How long will it take, not her, take him to catch up with, let's go ahead and change that to take Daryl's brother, Daryl, to catch up with him. Okay, so let's fill in our table here. We know right away that Daryl is traveling at 2 miles per hour, and that his brother Daryl is traveling at 8 miles per hour. Now, here's where we have to think about one of them gets a head start. So Daryl's brother Daryl, it's asking how long will it take him to catch up. So let's let that be the thing we don't know. So how long is Daryl's brother Daryl traveling walking for? So that's going to be x, since the first Daryl traveled 6 hours earlier, he started 6 hours ahead, we're going to add 6 to his time. Now we can go ahead and complete our table because we know rate times time equals distance, so 2 times x plus 6 is going to be the distance for Daryl, and Daryl's brother Daryl will be 8x. Great, so we really want to know when their distances are the same. So Daryl, 2 times the quantity x plus 6, will eventually be equal to just 8x. And that's when Daryl's brother Daryl will catch up to Daryl. So we'll have 2x plus 12 equals 8x. We can subtract 2x from both sides, and we get 12 equals 6x. Divide both sides by 6, and we get 2 equals x. So that means it will take Daryl's brother Daryl 2 hours to catch up to Daryl. If you don't enjoy that, I apologize, but it makes me laugh inside. So Daryl's brother Daryl will need 2 hours to catch Daryl. Awesome. Thanks for joining us for these distance rate time problems where first we were traveling at each other, then traveling in opposite directions, and then having one person catch up to another person. Keep watching the other parts of our series for more ways to solve systems of equations in applications.